All right, let's dive in. Today, we're going to take a real GCSE computer science exam question and completely deconstruct it. We're going to break it down piece by piece, and most importantly, use the official mark scheme to figure out exactly what you need to write to get full marks. Ready to crack the code? Let's do this.
Okay, so if you're studying for your GCSEs, this kind of paper probably looks pretty familiar. And let's be real, seeing it for the first time can be a little intimidating. But here's the secret. It's not just about knowing your stuff. It's about knowing how to answer the questions they ask. And today, we're going to master one that gets right to the heart of how programming languages actually work.
Now, before we even look at the question itself, we need to get our heads around a really fundamental concept, the big difference between high-level and low-level languages. Trust me, understanding this is the key that unlocks the whole thing.
So think of it like this. On one side, you've got high-level languages. These are things like Python or Java. They use words we understand, so they're way easier for us humans to write and fix when things go wrong. On the other side, you've got low-level languages. These are almost speaking the computer's native tongue, all ones and zeros. Now, that makes them a lot harder for us to work with, but it gives you this incredible direct control over the machine itself.
Okay, with that foundation in place, let's get to it. It's time to decode the actual exam question we're looking at today. This is question 7A, a classic 2-mark challenge.
And here it is, word for word from the paper. Give 2 reasons why some programs are written in a low-level language. It's a pretty straightforward question, right? It's just asking, why would a programmer ever choose the harder but more powerful option?
And notice that number, 2 marks are up for grabs. That means they're looking for 1 mark for each solid reason you give. Our mission? Secure both of those marks with answers that are super clear and precise. So, how do we guarantee we get those marks? Well, we don't guess. We go straight to the source, the official mark scheme. You can think of this as the examiner's cheat sheet. It tells us exactly what they're trained to look for.
Okay, the first perfect answer you can write down is direct control of hardware or memory. It's short, it's to the point, and it's exactly what they want. But what does it actually mean?
That means your code isn't messing around. It's giving commands straight to the computer's brain, the CPU, or its memory, the RAM. There's no middleman. This is absolutely essential for things like device drivers. You know, the software that lets your computer talk to your mouse or your printer. You need that super precise, direct control over the physical hardware.
All right, the second killer answer is just as simple. Faster execution time. Boom! Another full mark right there. So the next obvious question is, why? Why is it faster?
We'll think back to high-level languages. For the computer to understand them, they need a lot of translation, and that translation process takes time. A low-level language, on the other hand, is already speaking a language the hardware understands. Less translation means the program just runs way, way faster. That's why it's perfect for things like high-end video games or complex scientific simulations, where every single nanosecond counts. So let's zoom out and lock in the big lesson here. Because this isn't just about grabbing 2 marks on one question, it's about really understanding a core principle in how all software is made. So, if you walk away remembering just one thing, let it be this. Why would you ever go low level? It all boils down to 2 words, power and speed. The power for that direct absolute control over the hardware, and the speed for the fastest possible execution. Get those 2 points down, and you have absolutely nailed this question. And that brings us to a final, bigger thought. This trade-off, between something being simple and easy to use versus being incredibly powerful and complex, it isn't just about code. It is everywhere in technology. So have a think about it. Where else do you see it? Thanks for joining me.